modeling data with quadratic functions. You have a definition. Write down your definition. Standard form of a quadratic function. F of x equals ax squared plus bx plus c is the standard form.
That is complicated. Isn't f of x the same as y?
Yes.
So we can write y equals y.
Your quadratic term is ax squared, your linear term is bx, and your constant term is c. So for something to be a quadratic function, you need an x squared in there. If you're missing the ax squared, if you just had f of x equals bx plus c, what type of function is it?
It's a linear function.
Linear function. Okay? So you have two choices right now in this first example. You have a quadratic function or a linear function. Okay? Alright, the first example, you had to determine whether the given function is linear or quadratic, and you have to identify the quadratic term, linear term, and constant term. So in the first one, y equals 2x plus 3 and x minus 4, you have to FOIL. So when you FOIL, everybody remember how to FOIL? First outside, inside, last.
What?
First outside, inside,
It's so
last.
convenient that it spells foil.
We should have a foil day.
Alright, so when you FOIL 2x plus 3 and x minus 4, first would be 2x squared. Outside would be minus 8x. Inside would be plus 3x. Last would be minus 12. Combine like terms, combine the middle two to get minus 5x. So is that a quadratic or a linear?
Quadratic.
Quadratic. What is your quadratic term?
2x squared.
2x squared. Linear term?
5x.
Negative 5x. And your constant?
Negative 12.
Negative 12.
That's easy.
Okay, here, same thing. Distribute the 3. You get 3x squared minus 6x minus 3x squared plus 6x. The 3x squareds cancel out. What are you left with? Negative 6x plus 6. So is it quadratic or linear?
Linear.
Linear, what's your linear term?
Negative 6.
Negative 6x, constant
6.
6. What's wrong?
How do you know it's linear and like?
If it does not have an x squared, your two options here in this chapter, they're going to be a quadratic or a linear.
Oh,
Okay,
okay.
if it does not have an x squared, then the answer is linear.
But if it does, it's quadratic.
Correct. All right. Now make sure, if I did not have this 5x, if I have 2x squared minus 12, it's still quadratic. Okay. If you just had 2x squared, y equals 2x squared, still quadratic. And when it asks you to list the linear term and the constant term, you just put 0 down. Okay? Now, here, for your quadratic term, there is no quadratic term. Yeah.
Does it always have to be in that order?
Yes. ax squared plus bx plus c.
So if it was y equals negative 12 plus 2x squared minus 5x, it wouldn't be.
You gotta fix it so that it's.
Well, it's still quadratic, but you just have to put it in standard form. Okay? Definitions.
What did you say would be 0 in the first equation?
If you were missing the linear term or the constant term, they would be zeros.
Let me see the music.
All right. Write down these definitions. The graph of a quadratic function is a parabola. Does anybody know what a parabola looks like?
A little u.
A U shape. Right now, your U-shapes are gonna either open up or down in this section. The axis of symmetry is the line that divides a parabola into two parts that are mirror images. Because a parabola is symmetrical, you have to have an axis of symmetry. And the vertex is the point at which the parabola intersects the axis of symmetry. I'll give you a minute to write that down.
Who's Fred Turner?
Who's not finished? Okay, moving on to the next example. We'll come back to it. Next example. Below is the graph of f of x equals 2x squared minus 8x plus 8. Identify the vertex, axis of symmetry, and points P prime, that symbol stands for prime, and Q prime, corresponding to P and Q.
What?
And the range of f of x. So, just by looking at it, the vertex is this point at the bottom. Vertex is the point that both sides come to. So, we should be able to look at this and tell the vertex is 2, 0. Once you know the vertex, you automatically know the axis of symmetry. To get the axis of symmetry, it's always going to be the same as the x-coordinate in the vertex. Here's the axis of symmetry. What type of line is that?
Vertical.
Vertical. It's always a vertical line when the graph opens up and down. Okay, right now all we're doing is up and down. So your axis of symmetry, the equation of any vertical line is x equals a number. In this case, it's x equals whatever the x-coordinate of the vertex is. So once you have the vertex, you automatically know the axis of symmetry. In this case, it's x equals 2. Okay? Now, corresponding points, since a parabola is symmetrical, you always want to pick corresponding points when you do your table. We won't get into the table yet. But here's P. What's the coordinates of P?
1, 2.
1, 2. So P prime needs to be the same distance from the vertex on the other side. So it is what? 3, 2. Okay? Q is 0, 8. So what is Q prime?
4, 8.
4, 8. Now, the last part of the question, I don't have the answer up here. What is the range? What is range? What's the definition of range?
The greatest.
What's the definition of domain?
The x value.
Domain is the x values, range is the
Y.
y value. So what's your smallest y value in this graph?
0.
0. What's your largest?
8.
8.
No.
Infinite.
Right. So your range, you can write it like this. Range is y is greater than or equal to 0. All numbers greater than or equal to 0 is how you would write it.
If there was a -1 below the 0 showing, would it be y is greater than or equal to -1?
Correct. If -1 was on your vertex. So basically you take the smallest point of your vertex and it goes all the way up if the graph opens up. Okay, so if it opened down, in this case it would be y is less than or equal to 0. Okay?
I didn't get when you how you got P and Q. How you got P and Q in?
Okay, hold on one second. All right, P and Q were given to you. P and Q will be given to you.
Really?
Yeah.
Okay.
And all you have to do is find the corresponding points, which is P prime and Q prime. So on the quiz and test, or even in your homework, the black points will be given to you, so you know the coordinates are 1, 2.
Yeah.
Okay, so you should be able to match up 3, 2 with that.
You just add, I mean,
You want to pick points that are the same distance from the vertex on opposite sides. So how far is P from the vertex? 1 unit, right? So the vertex is at 2, P is at 1. So you want to pick 1 unit on the other side of the vertex, which puts you at 3.
and then pick the same vertex, I mean, pick the same,
It's got to have the same y coordinate. Corresponding points have to have the same y coordinate, and you'll see that when we do our table.
okay.
Are P and P prime and Q prime always gonna have the same Y?
Y value, yes. That's why we pick corresponding points.